I'm CEO of 3D Robotics. We have 2 factories, one in San Diego, one in Tijuana. About 52 employees. We'll do about $10 million in revenues this year. Just closed a $5 million VC round. We are just now building, we've got 3 pick and place lines, which is building 2 CNC lines, building a injection molding line. I'm now an industrialist. Anyway, I'm just going to tell you my story and how I went from like the kitchen table and the soldering iron to factories in Mexico. And I can tell you, I knew none of this 5 years ago. I was literally, I was like, start with Lego. So there it is. I got 5 kids. My dream, my only real hope in life is, I have several hopes, but my big hope in life is that my children get interested in science and technology. There's absolutely no sign of that yet. But I haven't given up. We're constantly doing projects.
What are they?
I've got 5 from 4 to 15. Universally uninterested in science and technology. Which is really kind of frustrating, as you might imagine, for the former editor of Wired. My wife's a biologist, and the kids just like, anyway, we're playing video games. But I don't give up. I'm constantly coming up with projects that I think will interest the kids. And one day, as editor of Wired, we got these things in for review, these products in, and we got Lego Mindstorms in, which was, it hadn't even been released yet. It was the 2.0, and we got the beta unit in, and I was pretty excited about this. They were like, on Saturday, we're going to build a robot. And then there was this radio control model airplane that came in. And I was like, and I guess on Sunday we'll fly a plane. I thought, cannot go wrong. I mean, this is a geek. I started a whole site called Geek Dad. Have any of you heard of Geek Dad? Okay, so I started that site specifically to get my children interested in technology, geek stuff, and once again, the site was a fantastic success. My children had no interest. But this was going to be the weekend that we were going to have the Geek Dad triumphant weekend. So on Saturday, we followed the instructions and built the Lego tripod, 3-wheeled wheel. So it took all morning. It's a 3-wheel robot, and it goes, and when you're done all the programming, it sees a wall and backs up. And the kids are like, "You're kidding me." We've seen Transformers. We know what robots are supposed to do. And I realized that you cannot compete with Hollywood CG, with robotics, and so they were completely interested in it. But then comes Sunday, we're going to fly a plane, and we went to the park. I launched the plane and went straight into the tree. And if that wasn't mortifying enough, I then climbed the tree to retrieve the plane. The kids are like, Dad, as we predicted, that sucked, and we now need to get ice cream. So it was kind of a failure. And I was really frustrated with them, I was frustrated with me, and I was sort of like, this weekend was going to go so well, and what happened? And I thought, I went for a run, I thought, how could that have gone better? And I thought, I bet the Lego could have flown that plane better than me. I thought, actually, maybe that Lego could have flown the plane better than me, and so this is the world's first Lego autopilot. This is Lego Mindstorms with a gyro, the gyro sensor, accelerometer sensor, magnetometer sensor. Actually, I probably got one of those wrong. That's magnetometer, that's the gyro, that's it. Accelerometer interface to radio control, and this is the world's first Lego autopilot. And we put it in a plane, and this is the world's first Lego drone. This is now in the Lego Museum in Billund, Denmark. I'll have you. I was on the Lego advisory board, so it was kind of easy sell. But there it is. I did this with my children on the dining room table with Lego. And I had to Google like Kalman filter, and I had no idea how to do any of this stuff. And it did not fly well, by the way. But it did fly, and it did sort of was an autopilot. And then I had a friend who worked in D.C. for the government. He said, technically you weaponized Lego. Like what? I said, yeah. So autopilots are regulated as cruise missile controllers. They're covered under ITAR, the export control restrictions. And when you export an autopilot, you need to ensure that you have that's in a secure facility, and you have a 24-hour closed circuit television on it, and you have a login. You can have a logbook, so you know who has access. We're talking about Lego. I said, yeah. According to the rules, Lego is considered cruise missile control. If you allow it, if you program it to control a plane. So obviously there was something had gone weirdly wrong and different since the day those regulations were written. And what happened is when those regulations were written, this stuff was hard. This was, gyros were these like massive, like one-axis gyro was the spinning compass, basically. It was this spinning gyroscope. It was a mechanical device. It was about this big. It weighed like 50 pounds. It cost like $10,000, and that was one axis. And and these things didn't exist. And now what happened is that this changed the game. That the smartphone revolution created these MEMS sensors and ARM processors and GPS and cameras and memory and wireless and all this awesome stuff, and that basically the peace dividend of the smartphone wars is that the technology for things like drones and robotics in general is now available in Radio Shack for a few bucks. And this wasn't true 10 years ago, and now it's super. You guys all know that. You wouldn't be here if you didn't know it. But what's going on inside smartphones is Moore's Law is happening faster than ever happened before in history. Thanks to the economies of scale and the competition going on in smartphones, these components are now available to all of us. And the reason this is possible is that Lego was one of the first to put them in a little package that was easy to use. And I didn't know I didn't know how to spell MEMS, but I didn't know how to spell Lego, and so this got us into it. Well, it turns out Lego is, although a great way to start, not the perfect autopilot package. It's expensive, it's somewhat bulky, and so I went on and I said, well, okay, my children lost interest, but I'm kind of going to see where this goes. So I started a site called DIY Drones, specifically to be stupid in public. My only kind of guiding principle is that sharing your ignorance is a good way to get smarter. And so I would just ask dumb questions and post things I found, even though everyone else already knew it. It turns out lots of other people were starting to ask some of the same questions at the same time. Today today this is the biggest robotics site in the world. We do 2 million page views a month. We're now up to 35,000 members. And all because, and I knew nothing about this. It just happened to be the right moment when all that smartphone technology was kind of getting out there. And we've seen this picture happen in Silicon Valley many times, when kind of an industrial technology suddenly becomes cheap and easy and available, and then suddenly regular people start to do cool things with it. So I started this site, and the site was largely just a kind of a social network. It was an opportunity to talk about this stuff, but people started collaborating on the site and designing things. And hardware design, software, code, Arduino, etc. And then as it got easier, people started to say, well, could you make this for us? Could you manufacture these things so we don't have to make them ourselves? And so we started doing that. And this is kind of this is the link I was telling you about. These are just the sort of the components. This is an autopilot board right here. This is one of our APM2, and it uses basically an Arduino with a lot of fancy sensors attached to it. But these are the same sensors you find in an iPhone, same GPS. It's basically just an iPhone in a different package. But it's open source and and easy to program, etc. But that was the breakthrough. And this is where we started. This was our first Arduino compatible autopilot, which we made, and this is where we currently are. It looks like they're all. See if I can find a copy of it. It's a little box. And you can, looks like this, and it's $140 by itself, $170 with a GPS and sensors and cables and all this kind of stuff. And this is a universal autopilot. You put this little box in any vehicle, and now it's a fully autonomous drone. Helicopters, airplanes, multicopters, cars, boats, etc.
So do you have libraries now for common filters and such?
We have direction cosine matrix and quaternions and Madwicks and common filters, and we have something on board called the InventSense chip has a built-in thing called a digital motion processor. So we have sensor fusion up and down. And we have hundreds of developers, and they're all super smart. And I still don't know how to program a common filter properly, but yeah, it runs all of that stuff. I mean, this is the most complex Arduino program ever written is running in here. Absolutely no credit to me. I mean, I'm just the janitor who got the site going, and a bunch of developers came together. And by day they work for Google and Microsoft and Apple and IBM and etc. And by night they code autopilots, for the community and give it away for free. Anyway, so that's what we do. We then worked with a Swiss team out of ETH, we moved beyond Arduino to the Cortex M4 ARM-based platform. And this is what it looks like here. And so this is now, this really is now kind of an iPhone-like stuff. These are basically smartphone chips and have all the sensors on board, and it's even cheaper. And so this is kind of amazing. These autopilots used to literally cost tens and tens of thousands of dollars, hundreds of thousands of dollars, and now it's like about $100. Now without the GPS, maybe 140, and soon it'll be 99, and maybe it'll be 49, and then it'll just be everywhere. And this is like the military-industrial technology, and it's just like super easy and cheap now. So this is so what this enabled was the notion of personal drones. And when you think about the history of Silicon Valley, it's basically taking industrial technology and adding words like personal and desktop, the personal computer, desktop publishing. And we just did the same thing with this. The internet was a military technology, and then we made it the personal web. And we just did the same thing with drones. We think that that the real application of this technology is only going to be discovered when we put it in the hands of regular people. And so by making them personal and easy to use, so you've heard of the Parrot AR drone, which is a lovely bit of gear, but not a drone. It's not autonomous. It doesn't know where it is. You can't do mission planning, etc. So what we do is we just sort of swap it out. It's got limited to Wi-Fi range. We just take out the guts and we put in our own autopilots and make it a fully real drone, programmable GPS, unlimited distance, all this kind of stuff. And this allows for things like like look at here's just one example: disposable drone. I can tell you that Lockheed Martin and Boeing are not going to create disposable drones. Their drones cost millions of dollars. But the reality is that this stuff costs it costs tens of dollars. And so we know so we work with teams that put these drones, put these autopilots in airplanes that are made out of biodegradable foam, made out of starch, a kind of corn-based substance. And so they fly them over the ocean, do their mission, and then when they're done, the battery dies, they just land in the water and they melt. And the little metal bits fall to the bottom. And that's the kind of thing that only is possible when these drones are basically cost less than less than a flare. When they cost tens of dollars, you can just sort of spread them out there and send 1,000 drones out to map an entire area rather than one very expensive drone out with a FAA clearance and an aircraft carrier to support it or whatever to do a mission. You can just send cheap sensors out and let the sensors return the data, but you don't really care where the vehicle comes back. So anyway, so this is the kind of this is what I say is a universal autopilot. This is what I mean. You put the box in any vehicle, and you just click the button. What kind of vehicle is this? Is it a car? Is it a plane? Is it a traditional helicopter here? Is it a quadcopter? Is it a hexacopter? Is it an octocopter in this configuration so the camera can see out? Is it a tricopter, which again 3, but the camera can see out, or is but it has a mechanical servo, which is a little complicated, or is a tricopter in 6 configurations? So you've got 3 props spinning clockwise and 3 counterclockwise, which is mathematically simpler, or an octocopter in that. Anyway, so we just you just push the button, and suddenly that vehicle becomes a fully autonomous, GPS guided drone. So that's kind of cool. That doesn't exist before. That didn't come out of the military industrial complex. That came out of a community of volunteers and amateurs who just did it. And this is what the mission planning looks like. You don't fly these things. You can if you want to, but ultimately they're not meant to be flown. They're meant to fly themselves. We don't think that humans should operate heavy machinery, drunk or not. We think computers do a really good job of this. And so what you do is you just on the mission plan, you just click on the map and you just there's a waypoints, you assign waypoints functions. And the functions can be things like like land or take off or loiter or look at a region of interest and ROI. Go to different altitudes, follow the terrain. All those are kind of functions that autopilots can do. One of the interesting ones is that this isn't why does anybody need a drone? Why does everybody need a drone? Maybe they don't, but there are some functions that you just don't think about. Like for example, I told you my initial experience was flying an RC airplane into a tree. I crashed. I suck. I'm a terrible pilot. Well, the nice thing about this autopilot is that it allows you to be a better pilot. It's a fly-by-wire device, and so fundamentally it won't let you crash. What you just do is this is when you're at a field, you just this is your home. You just say this is the boundary box. I don't want it to fly out of that box, and the box has the floor and the ceiling as well. And it will not fly out of the box. So you can give it to a kid. You can give a controller to a kid, and you can just sort of say, do what you want. And the kid can just slam the stick forward. It goes screaming down as a dive, and the moment it hits the bottom of this virtual box, it takes command away from the pilot. returns the drone to the center pod, the return spot, and then just loiters there, waiting for you to take control over again. And this is just a track of trying to crash an airplane. And you can see when it hits the boundary, it suddenly takes control away, returns it to the return spot. Likewise, if you get into trouble, you just let go of the stick, and the plane levels itself. Fly-by-wire means that one of the things that confuses pilots, people about flying planes, is that if you're used to a car, when you're in a car, when you steer, if you move the steering wheel, 45 degrees to the right, it'll hold a 45-degree turn, right? So if you want to hold a turn, you move it to the right. But on an airplane, if you move the stick to the right, it will roll. It will just continue increasing its bank level until it rolls and you're upside down. It's crazy. So cars and planes fly differently. This confuses people when they're first learning how to fly. But in fly-by-wire mode, you can have the stick move like a car. So when you move the stick over to 45 degrees, it will hold a 45-degree bank, and exactly as a car would. So it's an easy training guide. So these are just kind of ways that, again, the military didn't develop autopilots, so that children can learn to fly model airplanes, but the reality is that they can. We think that even that whole radio control interface is too complicated, the whole sticks and buttons and things like that, so we're moving to a tablet interface, and this is something called Mavless, which is using the Mavlink communication standards on an iPad or any device, not a phone. It runs on the browser using HTML5. And on this one, you don't even fly it anymore. What you do is you just double tap, and it goes there. You just sort of double tap, and it goes there. Or you can say, look at this region of interest, etc. But it's a very different construct. Once the computers fly aircraft, you don't think about flying. You think about the mission. What do I want to get done here? I want a camera here. I want a camera to see that. I want the camera to follow this. And so it becomes very mission-oriented, which means that anybody can do it, and that's why the tablet interface is really good at. Unlike things like the Faraday air drone, etc., that actually make you tilt the tablet, make you fly with the phone and the tablet using the accelerometer or tilting it. It's very unnatural motion. We just sort of think that flying is something the computer should do for itself. One of the other functions is the follow me function. So if you're a windsurfer and you're doing some awesome performance, you probably want video of it. It's actually quite hard to video windsurfing from the shore because you're too far away. And the real angle is up in the air, about 30 feet up and 30 feet back. So what we're going to be releasing shortly is a follow me box. It's a little box you put on your belt, and it has GPS and a radio transmitter, and the copter, of course, also has. This, by the way, is what the copter closely. And this is the copter. This is the copter with the GoPro. And what you do is you just sort of say, you push the button, and the copter takes off from the beach, comes out, positions itself 30 feet up and 30 feet behind you, and actually you have a rocker, so you can decide, do I want it here, do I want it there, do I want it there, do I want it here, based on where the sun or the wind is. And once you decide that position, it then just follows you. Whatever you do, it just follows you with the camera focused on you. And then when the battery gets low, it flies back to the beach. So that's kind of cool. Again, that's you don't think of that as being a drone function, and yet that's exactly what drones do really well.
How much will it cost?
It's going to be under $100. Under 100 for the box.
Will it avoid the kite if
We do not have sense and avoid technology yet.
So no kiting?
Well, you can kite, but you just need to position it so it's not within range of the kite.
Always upwind. Okay.
Or upwind, yeah. Upwind
Always upwind.
Yeah. Interestingly, water is a great one for us because it's a two-dimensional surface. There's no trees. There's very few other people, and we handle the wind fine. Snow is actually really hard because it's you're on a three-dimensional surface. You got trees, you got other people, and so yeah.
Usually, when you windsurf or you kite surf, you have a lot of other windsurfers or kite surfers. So
that's true.
No trees, but a lot of kites.
That's all. That's true. We'll just position yourself so you're above the kites.
That's right.
Yeah, but fundamentally, this is not gonna destroy a kite. I mean, it'll fall into the water, and
you're gonna lose it.
Sorry,
you're gonna lose it.
Yeah, you might lose it. You might.
And how much is gonna be the?
How much is this, sir?
Yeah, the box.
Well, the box is going to be about $100, about $90.
But not the drone.
The drone costs about $500 to $600, depending on how you configure it. We'll probably be bringing it down a little bit, but the drone's sort of going to be in the $500 range. Right now, it's a $600 device, and then the box will be $100. Yeah.
And if you're to position a unit on top of, say, a vehicle for off-roading, not necessarily racing, but
well, you can do that right now.
Speed.
So right now, we already have the follow me function. We've had this that in the software, but right now you need to plug into a laptop.
Right.
So what you do is you get one of those little GPS, USB GPS devices. You plug it into a laptop, put the laptop in your car, and it'll follow you as long as the battery lasts.
Cool.
Interestingly, it's a trivial problem for copters because they're very good at sort of positioning themselves randomly in the 3D space. It's actually a hard problem for airplanes because copters can be stationary, but airplanes can't. And so to turn sort of, I would like you to optimize around this view into a command for an aircraft that's flying in a big circle is, and you've got wind and you've got motion. It's actually kind of a PhD level pathfinding problem. Doable, but not trivial. Anyway, so that's kind of one of the other functions. As a company, what we did is we started as a community site, which is where all of our software development is done and documentation and that kind of stuff. And that's a nonprofit. But then as people asked us to make stuff, we started a company, 3D Robotics. And so we started with my co-founder, Jordi Munoz, who I just met, one of the first guys I met on the internet. This is him on the cover of Make last year. And he was just doing awesome stuff. He was flying a helicopter with a Wii controller using Arduino, and I just thought he was just the smartest guy on the space I'd ever known. Only later did I find out that he was a 19-year-old living in Tijuana, just graduated from high school. And today he's president of 3D Robotics, and he's 25. This is the team is mostly Mexican. They're mostly just these kind of awesome engineers who grew up in the San Diego-Tijuana border. And we have one operation in San Diego, one in Tijuana. And if I were to leave you with one message is Mexican engineers rock. If you're looking for great engineers, if you're looking for manufacturing capacity, they spent the last 20 years after NAFTA learning the electronics industry as well as anybody. That's where the Samsungs and the Sonys and the Foxcons are. That's where all of our TVs are made down there in Mexico. They've been picking up multinational electronics assembly skills, and they're cheap and they're good and they work super hard. Their English skills are great, and Mexico graduates more engineers than the United States. And you want ISO 9000 production ability, go to Mexico. You want E&E and EE, who understands pick and place machines, go to Mexico. So it was just complete random happenstance that I met, that the first guy I met who blew me away was Mexican, but today it's kind of our secret sauce. And we've reached price parity with China on manufacturing capacity, and I think we've got a superior innovation model with the open source, community-based one. So anyway, we'll talk more about that in the Q&A. 3 years ago, 4 years ago, this is how we were starting. This is me. We had a robot blimp kit that was kind of cool, and people wanted it, and they said, "Can you make it for us?" And so I got my children. These are some of my children to put the kit together. As you can see, although we don't pay our engineers, our production workers in Mexico that much, we do actually pay better than I pay my children, who are paid in strawberries and shoes. A couple lessons: do not put the 6-year-old on quality assurance. Not only will she not do a great job, but customers are completely unsympathetic when you tell them that the missing parts were due to the fact that a 6-year-old packed them. Lego donated a lot of Lego pieces for the kit. We laser printed stuff, got some electronics. It's we sent some boards out to. Anyway, this is how we started. I think many of you probably recognize scenes much like this. Maybe you don't use as much child labor, but there's much to be said for the dining room table. Then the next one, Jordi started the dining room table with a reflow oven from Target, but then he got a garage, and here we are in the classic garage scene with Jordi and Lorenzo, who's now our operations manager. This is now like a tiny part of one of our factories in the back, and this is just a glimpse of part of our Tijuana facility where they now wear uniforms and have, electrostatic discharge booties, and these are basically people who yesterday they were working for Sony and now they're working for us. I think that's kind of awesome. So that was 3 years, from children being paid with strawberries on the dining room table to ISO 9001. Pick and place CNC, ESD facility, 52 employees in Mexico, and did that with zero funding, credit cards, and we were cash flow positive on day one. Hardware is awesome. The great thing about hardware is how people struggle about business models in software. There's no struggle in that business model. We sell products for money.
This is so crazy.
I know. You know what? We charge more than it costs. Not too much more, just enough.
You're in the valley now. People don't. You have to explain this.
Now, in fairness, my current book, my most recent book, is called Maker's Result. That's my previous book was called Free, which is I was responsible for the whole confusion about how
You're learning.
Well, you know, bits are one market and atoms are another. We give away our bits for free. So all of our software, design files, and intellectual property, everything is all given away for free, licensed for commercial use. But our hardware is atoms. There's some real costs associated. No one expects the hardware to be free. No one complains. Our price, we have a actually I'll talk about this in a second, but our pricing model is super simple. We charge 2.6 times the bill of materials. That's one 40% margin for us and one 40% margin for our distributors.
I missed that. What?
2.6 is our multiple of 40% margin for 40% wholesale, 40% retail. So this is what. So when people say, "Oh, the editor-in-chief of Wired magazine," I was the editor for. Yes, sir.
Yeah. For the manufacturing, did you leverage contract manufacturers, or did you build?
Yeah, we started with contract manufacturers. We did China. We did advanced circuits. I'll talk a little bit about it. That way lies madness. Right. What we discovered is that let me just sort of just take China for example. And I lived in China for 4 years in Shenzhen. You know, I completely get China, and we love the skills. But here's the 3 terrible things that happen when you outsource to China. Number one, all of your capital goes into the supply chain. So you have to order in high volumes. You know, 5,000 to get decent pricing. You have to order 5,000, 10,000, whatever. So you have to pay for those up front. So your capital goes into the supply chain, and you pay up front. And then it has to come all the way back through the supply chain, into your distribution channel, into customers, and back, and only then do you get paid back. So capital, it's basically your capital's dead and locked up. Number two, if there's any mistakes in your product, you're screwed, right? I mean, you had to order 5,000 of them, and you guys who do hardware know what it's like to have that, to push the button and say, okay, run the lines, and then realize later that you made a mistake. And the third one, and this is the most crippling, contract manufacturing, outsourcing, especially 9,000 miles away, is a huge disincentive to innovate. Because you ordered 10,000 of those. You cannot change that design until you've sold all 10,000. And so you sit on your hands for months or years go by waiting for that first batch to sell out, because that's where all your cash is, before you can iterate and change the design. So today we shorten the supply chain and do just-in-time manufacturing so we can change the design every day. And on some products we do change the design like every week. We'll just switch in a component, or we'll move a trace, or we'll make it more, increase the yield. We can do that because we do 64 at it, 64 in a run. And our capital is now super efficient. And by the way, pick-and-place machines cost, our first one was like $3,000. They're not that much. And so our capital is now we have really efficient capital flow. When we make a mistake, we only lost 64. We fix it, and we can innovate as fast as our community wants us to. So we can innovate as fast as the designs come in, and we can produce more stuff. So this is the biggest lesson we learned is do your own manufacturing. It's the only way you can maintain quality and keep your innovation up. Yes, sir.
So that's a very interesting thing about it. You can have small batch sizes. How do you do you have like a set of regression tests, or how do you ensure you keep the high quality control you need as you're going through these constant iterations and supporting potentially hundreds of different revisions?
Yeah. Well. So we have about 400 SKUs at this point. We have a big QA department, lots of test jigs, and a very good process. And also, because our manufacturing process is co-located with our engineering team, or at least our San Diego version of it is, we have a very tight feedback loop. So when the QA team says, look, the yield just went down on this design, what's going on? We'll get an answer within hours. The engineering team's there. They'll do the diagnostics. We'll look at the component sources. It's almost always something we can spot immediately, and then we'll fix it right like that. So before the day is over, we've diagnosed the yield issue and corrected it. And we find that it's not like we forget. It's not like if we don't do that batch again for a week, that we have to start from scratch again. The processes, because we do the ISO 9000 process, everything's documented. We use with our pick-and-place machines, we use smart feeders so that the machines know when you load the things. The machines know what the components are. We use barcode scanners to do inventory. We have an ERP system. I mean, 3 years ago we were on a kitchen table, and now we're like upgrading our ERP system. I mean, I couldn't like spell ERP 3 years ago, and it's just process. You know, it's once you optimize your system around just-in-time manufacturing, you recognize the complexity is baked in, and you just need good software and processes to handle it.
So how does that work with things like FCC approval? Because if you move trace, you have to reapprove
Yeah.
many devices.
Yeah. I mean, how should I answer this? We have there's active emitters and passive emitters, right? So active emitters are radios, the various sorts of passive emitters are just all of our stuff. There is so by and large we sell largely when we sell a board like this. This is not considered a finished good. It's not considered a consumer good. It's considered a developer board, and typically that does not have to go through SEC approval. For things like radios, typically what we're doing is we're taking a commercial RF chipset and putting it on a board. And we actually have, on that one we are submitting for FCC approval for our radios. And on that one we don't change the traces all the time. But for our passive
You do your
emitters,
own compliance?
we have a partner who does compliance with us. We have both a local consulting firm, and we actually have a guy in Australia who's part of our dev team who gives us a good deal. Yeah, exactly. But yeah, basically we're not submitting our passive components for FCC, but we are submitting our actives.
Generally, even if you have a module, you might have to reference modular approval, but in terms of if you have a product which is made of several things, even with the radio, and even you change the non-radio things, they kind of often want that.
I mean, what can I say?
I mean, it's a lot of it is letter written, how no one checks.
Yeah, we are, we've gotten a lot of good advice from our friends at SparkFun about this. We do understand that at a certain scale you probably should, check all the boxes. Most of our sales are outside the United States. By and large, we kind of, move very fast, and we kind of evolve processes, more slowly. But, when, someday maybe all of our products will have the FCC. How many people in this room make and sell hardware? How many of you have gone through the FCC certification process? Yeah, exactly.
I went to DesignCon this year just to avoid chambers and paying for it, the hard way.
Yeah.
And they now have RF options that you can do Garfield, EMI problems all by yourself.
Yeah, and ultimately we'll get there. We'll use smart software. We have a consulting firm that does give us a pretty quick answer on stuff, but we've got 400 SKUs. Most of these are just not really. No, they're not going to upset anybody. Active emitters, we think are something we should.
What about when you started, especially about OSHA and things like that? It can hurt people. The drone. So
OSHA.
Yeah, like
OSHA's workplace. This is not typically not a workplace tool.
No other compliances when you sell these things to.
Yeah, so there's FAA. There's a lot of rules.
Human beings that can.
Well, you're asking a number of different questions. The FAA has rules about use of unmanned aerial vehicles in national airspace, so you have to stay below 400 feet within visual line of sight, away from built-up areas, away from airports, etc. So we're in compliance on that. There's export control, but again, the code is open source and created by the internet for the internet, so that's going to fall under the public domain exemption. We have so what we make is the hardware, not the software. The software is not sold; it's given away for free. It's created again not by us, by a volunteer community on the internet. So there's no product liability involving the software. For the hardware itself, we have liability insurance. It's as simple as that.
So liability insurance and that covers it, even in the beginning when you started selling it to people.
We'll see. We'll see. No, so far so good. I mean, these things are pretty small. They're not going to kill anybody. The airplane's made of foam. They'll bounce off your head. We largely keep everything at a very low level, so it doesn't cause a lot of harm. I mean, pretty much the worst thing this can do is nick your finger. I've got a little nick here from my finger. These props are flexible. It's once you get into the big octas with like 12-inch props, then I get a little scared. But we don't sell anything that's going to kill anybody. Yes, sir.
My question is, when you first started out, you say you had to have some prototypes made. How did you go about that? Was it something you found your buddy down the street with a lathe, or did you go out and buy your own lathe? Because that's the position I'm in. I got some
Yeah.
ideas, but I can't, I can outsource to China, but I'm not looking at spending $10,000 or more.
Our first products were just simple printed circuit boards. And we sent the PCB design files to SparkFun's batch PCB, and then we hand soldered them. And the next ones were advanced. So electronics was one thing. When it comes to our mechanical stuff, we started with hand crafting. We'd get like off the shelf rate of control airplanes and things like that, and we would just put them together ourselves. Then we got a CNC machine. What kind of product are you talking about? How complex is it?
It's not very complex. I can do AutoCAD images,
Right.
which I'm working on right now. It's a very simple idea. I don't want to get into it.
Yeah.
But my problem is once I get it done, I can. There's places on the internet in China that'll take my drawings and give me probably a price quote.
Right.
But I have other concerns. China is notorious for
Understood.
cost.
I'll ask the obvious questions, but we have 3D printers. Presumably, you've already been through the whole 3D printer phase.
I haven't even gone through that yet.
Okay, 3D printers are, especially if it's a somewhat structured thing. 3D printers are super cheap and easy right now. My children use a 3D printer every weekend, so I would definitely recommend. And 3D printer, you don't need your own. You can just upload it to a service like Shapeways and have it 3D printed. The reason you would use your own is because you just get the answer. You have to wait 3 weeks for the answer. 2D CNC is super easy. You can start with laser cutting if that makes sense. 3D CNC a little bit more complex, but again, even that there's services that'll help you with that. So so we use, for example, in our injection molding molds, we use Protomold for that, and they have smart software that will do it. But are you just looking for? Is it yours a mechanical device or simply a?
It's a mechanical device.
So 3D printing is not the right answer for that.
No, actually 3D printing might work. I'm concerned about the accuracy though. I'd probably have to go down to maybe 100,000.
It depends on the material. So plastics shrink. Some metals shrink, some metals don't. You're in the right place, right? The tech shop folks can help you. But if nothing else, just throw it on the machine and see what happens, right?
If you haven't had the tour yet, after we're complete here on the talk, they're going to give a tour of this place that maybe answers some of the questions you have.
Yeah, basically, there has never been a better time to give you answers to your question. My grandfather was an inventor, and he was a machinist. He knew how to use a metal lathe. He had awesome skills. I had none of that. But this is the golden age of prototyping. Literally, my children design things in Tinkercad and upload it to Shapeways, for fun on weekends. It's just super easy. You are definitely in the right place here. Yes, sir.
Short question about the legal part of it. Did you have any lawsuits filed already, or any patent trolls coming after you?
No,
not yet.
No. It might happen.
It might happen.
As you know, if you do a patent search, it increases your liability. So we were advised by our legal counsel not to do a patent search. There was one technology we knew was patented. We contacted the company to see to get a license. It was stupid. They had dumb numbers, and we just innovated around it. Right now our products, I don't think anomaly our products violate any patents. I think it's possible our software, and when I say our software, the software, might infringe on somebody's patents. Who knows with software patents? But the thing is, we didn't make it. We don't sell it. It was created by volunteers on the internet and given away for free on the internet. Who are you going to sue? You're not going to sue me. Yeah, you can try suing me, but I've got a pretty clear, legal distance from the software. That's a great thing about open source. It's kind of a jurisdictional problem. Good luck. Sue the internet. See how that goes.
You mentioned that a lot of your sales are outside of the country. Can you expand on that?
Actually, let me introduce John Chervini, my colleague who's sitting right behind you. Sorry, John, putting you on the spot here. John's our Vice President for Sales and Marketing, just working with me out of our Berkeley offices. But John, I know you just done an analysis of our sales.
Yeah, so it breaks down over the regular major countries that you would expect. So Germany, Australia, UK, all that kind of stuff. So it's pretty much your standard, big countries that you would expect. Other than the US.
Well, I wouldn't expect anything in particular. So I may not be the reference audience here.
Yeah. Well, it's your standard, your standard big 8 countries or whatever you want to call it.
It kind of breaks down by GDP.
Right.
And with the exception of China, which is this massive black hole because everything's cloned in China. We have no sales in China.
That's the other thing I was going to ask you about. I hear some people are now cloning your stuff in China.
Everybody's cloning all of our stuff. We get cloned within days.
So how does that work for you? A lot of people here have this concern.
A lot of people do.
A lot of people in this audience have this concern that I build something and then China clones it.
So, this is a really sticky issue. We are open source, not because I'm a zealot, but because it works for us. We give away stuff and we get back more in return. It creates confidence and trust in our community. It's kind of a social compact we have with our community. Plus, we're based on Arduino, so it's like legally required. And our code's GPL. Well, anything that's the Arduino derivative has to inherit the Arduino licenses. And so we GPL our code and we license the Eagle files for commercial reuse, etc. So, my left brain says I believe that this is an efficient innovation system. I believe that on balance we will get back positive qualities. Emotionally, it just bugs the crap out of me, right? I mean, it's like when we spend like tens of thousands of dollars and God knows how many months designing something, and the Chinese clone us in 7 days. I just want to go strangle somebody, and I just tell my emotional side to calm down, to count to 10. That in the big scheme of things, it's these clones are good for the community. It gives them more choice. It brings more supply into the market. It might bring lower prices. It usually does bring lower prices. Every now and then, a cloner actually improves upon our design, which is fantastic. They never put the design files back in the public domain, so they violate the license. Absolutely illegal. They violate our trademarks. I mean, it's just horrible. But nevertheless, I feel there's a little. The cloners are kind of like they're part of an ecosystem. They're perhaps a parasite, part of the ecosystem, but they keep the ecosystem honest and healthy. And if we have a product that costs $79 and a cloner's got it out there for $29. I take that and I walk into my production department and say, guys, what are they doing that we're not doing? How are they able to sell for $29? What can we learn? What are we doing wrong in terms of sourcing or component choice or production that is keeping us uncompetitive? And I use it kind of as a stick to beat our team with. I still feel sort of sick about the fact that they stole our hard work and never even gave us credit. And they copy our text and but that's me being emotional. Intellectually, I think open source works. Also, I should note that although the code is 100% open source in GPL, our electronics design files are open source, but we don't. But as I mentioned, we change the design like on a weekly basis, but we only release the design files on a unitary one. So on a 1.0 and a 1.5, we'll release those design files. All the little 1.1.1, 1.1.2, all those little sort of internal revisions, we don't release those simply because we couldn't document them. Those are production. They don't have any feature differences. They're only just for production efficiencies. So, the cloners complain that our design files aren't up to date, and we're like, you and then you, and I'll probably move forward with that slides. Yes, sir.
Okay, so far, and you may be coming up to this, but what's been like the biggest surprises that you'd want to share to someone else doing a hardware startup that you've learned so far in like your lessons today?
Well, I mean, our biggest surprise was that you can build a factory. It's just not that hard anymore. All of you can build a factory, and maybe you should.
What's your price in that?
When I say factory, you're probably thinking, belching smokestacks, etc. But you start with a room about this size. A pick and place machine. You can put a pick and place machine on this table. They cost $3,000 on eBay. You can buy a toaster oven from Target and put a little PID, a little Arduino to control it. So now you've got a reflow oven. You can do manual stencil, printing. CNC, you can use Tech Shop. Lots of companies, build microfactories in Tech Shop until they scale out. You saw our pictures. Our first factory was a garage. Our second factory was industrial space. We're on our fourth now. We're just signing a contract for 14,000 square feet. Of space. 14,000 square feet is a shitload of space. And we negotiated them from a 3-year contract to a 2-year contract because we know we're going to run out of space again. And this is 3 years. Thank you. This is 3 years after after being on the kitchen table. So I guess factories sound scary, and they used to be scary, but they're not that scary anymore. Don't think factory. Think fancy garage. And soon that fancy garage will turn into a fancy industrial space, and that fancy industrial space will turn into 2 industrial spaces, and then oh, sorry, that was amazing actually. I think my
You
laptop.
cheat the source there.
No, I think my laptop just typed out.
Oh, really?
Yeah, sorry.
Chris, do you have a lot more slides left?
Anyway, so the biggest surprise. Sorry.
How many slides do you have left? We're kind of running out of time.
Yeah. Let me. Not that many.
Yeah, it's all.
Let me zip through. Okay. Just to finish, this is going to come on in a second. Oh, do we have the wrong input?
I'll figure it out.
Thank you. So I'm just going to. So I'm projecting. So you just need to switch the inputs to not HDMI. Switch the input to VGA on the projector.
On the projector.
On the projector.
Oh.
Just switch to VGA.
Okay.
We're good. Okay. I have no idea how to Thank you. Okay. So this is what I learned from my 19-year-old Tijuana high school student co-founder. Arduino. Everyone laughed. They said, "I can't believe you're building a drone on an 8-bit controller." No, all these smarty pants engineers didn't realize it's not about the technology; it's about the community. Arduino was the best community. It was the best libraries. It was all social stuff. The Arduino social movement was huge, and by being part of that, we got huge advantages. We could start with good culture, good community, and add good technology. But you can't start with good technology and add but complex technology, and then append community afterwards. This is the kind of pick and place machine you can buy on eBay right now, plug. And they're super easy to use right now. And Tijuana, who knew, right? I mean, you guys probably think Tijuana's like heads on sticks, drug cartels.
That is impressive.
But yeah, well, I love it. Every time I see an article, I think more engineers for me. The city of 2 million. Electronics, the biggest export of Mexico. Every company is down there. Samsung, etc. Fantastic engineers, great production technology. 20 minutes across the border. You don't even show a passport. It's like driving from France to Germany. You do show a passport on the way back. But it's just it's 20 minutes. It's like we drive between factories in 20 minutes. Anyway, this is basically how we. This is our kind of our so-called hierarchy of reward. This is how we reward our open source contributors based on their contributions. So when your first commit is accepted by the dev team, you get a T-shirt, which people love, by the way. They didn't do it for that. They did it because to scratch their own itch to add a feature, add something you wanted. Then as you get sustained contribution, you get a hardware discount. Then if you become project leader, you get free hardware and become a dev team member. Up there, you get a trip to our dev meeting. John, can you say a word about DroneCon?
Yes. So DroneCon is going to be the day before ABC.
The Spark Fun Autonomous Vehicle Competition in Boulder on June 14th.
Correct. So the ABC starts on the 15th. We will be doing a DroneCon on the 14th. We're going to bring in our top shelf developers from around the world and have them give some talks on the technology that they're working on.
In the Spark Fun classrooms in Boulder.
It's in Colorado.
The autonomous vehicle competition is great. It is probably other things, dinosaurs. It's autonomous vehicles. It's just it's a circus. Spark Fun's the coolest place ever. Boulder's a great place to be. Now it's June as opposed to March. It was snowing last time we did it. That was tough. And we're going to have DroneCon. So what's not to like? Anyway, you get if you're a core team leader, you get a trip to that, and the ones team leaders who ship the project get equity in the company, which is kind of I don't know if it's unprecedented, but it's pretty rare to give equity in the company to volunteers from the community itself. But that's what we do. I think I mentioned a little bit about our business model. Super easy. It's like we charge money for stuff, give away the bits, sell the atoms. 2.6 times the bill of materials. We innovate faster because we have a better innovation model. Our starting rule was 90%, 91. We try to get 90% the quality of commercial for 1% the price. I think we're actually shooting for 110.1. We don't see no reason why the open source model can't be superior to the commercial ones, and 1% of the price. The military industrial complex, open source. You can sort of see we've got a lot of margin in there to play with. Military drones cost, little tiny helicopters cost $200,000 each. We think we should cost about $200 each. So we have factor of 100,000. No, that's not right. And we have a factor of 1,000 to play with, which is kind of cool. And we also think that the cool thing about democratizing technology is about making stuff available cheaply, easy, etc., is that it reaches a new class of customers. And as we know in Silicon Valley, when you take industrial technologies and give them to regular people, they come up with cooler things to do. And all the really interesting applications come from putting high technology in the hands of regular folks. And the way we create, the way we can build big business around low prices is high volume. We talked about open source hardware advantages, but it's fast R&D. It's free. We talked about the regulatory barriers, open public domain exemptions, liability, consumer protection. All those kind of things that are built around sold goods kind of go away when you're giving away things for free. It's kind of awesome. We sell products that are pretty good to customers, and the customers pay us for them. Then the customers make them better, and then we improve them, and then they buy them again. And they do the product support. They help a lot with the product support. And because we're in such huge volumes, we put about 30,000 drones out there in the marketplace. Just to give you a point of reference, the entire U.S. military fleet of drones is 7,500. That's about 1/4 worth of shipments for us. So every quarter we put more drones in the air than the entire U.S. military.
I'm sorry, how many per quarter do you put in?
About 7. We're scaled at around 7,000.
7,000.
Yeah.
Yeah.
Yeah. So and I'm not saying ours is better than the military ones. Ours are just crazy cheap, and available. And a $600 drone versus a $6 million drone, you can sort of see we got volume on our side. And the nice thing about getting 30,000 out there is that we got incredible testing. We basically everything that can go wrong has gone wrong. Every configuration that could be tried has been tried. Every user error and software bug, etc., all gets kind of discovered on that kind of volume. And so, although we have great regression analysis and auto testing and sims and hardware in the loop and software in the loop and all sorts of great testing things, there's nothing like putting tens of thousands of robots into the real world to find real issues. These are the hard things. We have some legal questions that we can talk about in the Q&A, but there's still some open questions about things like intellectual property. The complexity, because we don't control the whole chain, because we have software created by the community and hardware created by us, and because there's so many moving parts, because you can put it on any vehicle and any configuration, it's quite hard to guarantee reliability. And then there's that small cloning issue, which bugs the crap out of me, but it's probably just baked into the system. Anyway, this is the military. The great part is the way the military-industrial complex looks at drones, and this is the way we look at drones. Sort of every time you take an order of magnitude out of price, you get an order of magnitude increase in volume. And the military stops in the tens of thousands, and it's typically high tens of thousands. We sort of start below 1,000. We're going to below 100. And we see no reason why these things can't cost less than $10. When you talk about how the sky is going to get dark with drones, it's going to be because they cost a few bucks. This is you start to get into the smart dust kind of territory there. And but this is where we are. This is where we're going. And if you extend the laws of technology advancement, you're going to end up here one way or another, whether it's us or somebody else. So I just want to end with these slides. This is the first IBM PC. How did this happen? How was this developed? And this is a rhetorical question here in Silicon Valley. But was it A, by scaling down the mainframe computer, or was it B, by scaling up this piece of plywood and circuit boards? And you know the answer. This is the first Apple. It's the Apple I. We started here. We started with drones that looked pretty much like this. And we think it's more likely that we're going to be creating the IBM PC. When I say we, I mean our community, our movement, our philosophy. We think it's more likely that we, the grassroots, the regular people, the homebrew computing club, homebrew robotics club, the hackers, the makers, are going to be creating the future of aerospace, much more likely than the Lockheeds and the Boeings are going to be scaling down manned aircraft. And I wrote a book about this too. Thank you. Do you think a demo would be in order?
I was looking up to see one.
Okay, well, why don't we set up a demo while we're taking questions? And
here's what we're going to do. Some people, you're welcome to stay as long as you like, and I like you to stay and ask questions as long as Chris is willing to do this. Yeah, so, there are tours available. If you've never been to the tech shop, I encourage you to go to the front desk and ask for a tour. You can get a tour of this place, and you don't have to stay till the end of this, although I encourage you to.
A couple more announcements on that too. If you do not sign in, please sign in. One of the things, the tech shop was gracious enough to let us be here at no cost. So they do request that we log into the track for security purposes and nothing else. So there's a sign-up sheet. If you missed it for any reason on the way in, please sign in there. Secondly, besides thanking Chris for, there's some amazing people here. People that do manufacturing, people that do that are the engineers and inventors. It's the full spectrum of folks. And so, what I always like to say is, before you leave, make sure you met at least 2 people you didn't know before you came here, because you'll be surprised at the types of people that are part of this community. With that, then, if Chris, you're ready for your demo, I guess I'll let you go. Any general questions as far as solid state is concerned? All right. Thank you all. So,
are we projecting anything? No? Just hold up, John. I need to connect. Let's hold it close. So just to show you what's going on here, unfortunately I don't have internet access, so if anyone knows what the Wi-Fi access point is, this would normally be loading the map, but I don't have internet access on that. But basically that's the heads-up display. On the corner is John Schultz. You can sort of see that it's all wireless. This would be showing on the map. Again, forgive me for that. And that would be showing its position and its orientation and such. It's disarmed, which means the motors cannot spin up at this point. But John, maybe you can just show him how this works. So he's going to probably fly.
Yeah, I'm going to fly it over here. But yeah, I mean, so typically you just arm it from the RC. You can also fly it straight from the insert planner. You don't have to have the RC part of it.
Yeah, you can fly it entirely autonomous with auto takeoff, and you can even script it in Python. So you don't need a radio control at all. But for the sake, because we're indoors and because we don't have GPS lock. John's going to very gently.
Very gently. So.
How long will it fly in the charge?
About 15 minutes. So you can see you're getting full telemetry as you're doing this. It's also recording the whole mission, so that afterwards you can replay it, all the data fields. So you can rotate it around, you can yaw and all this kind of stuff, and the GoPro will be doing it. All right, John, thank you for that. So now these disarmed. This is the mission planning interface, and this would be, where we would be adding waypoints and point and click, and anyway. So you get the idea. Any other? So did you take questions or?
Yeah, if you want to take questions, I'm sure people have them.
Yes,
as long as you're willing to stay.
So what motivates you? You had a very exciting job before, right? So what makes you wake up every morning and be a part of it? So what drives you?
I think this is a once-in-a-lifetime, opportunity to invent a new aerospace industry. I mean, it seems like after these things don't come around very often, right? We had the PC, missed that. Internet, got it. I was lucky enough to. I was in the physics world. I was lucky enough to be using the internet in the 1980s, and so when Wired came along, I was on board. So I feel lucky to have gotten the internet, and this is the next big one. I mean, I think hardware is the new software. I think that this is an opportunity to use the web's innovation model to disrupt massive industries, and mine is aerospace. So I think this is my, I get to be able to build an aerospace company, built along web lines. I think that's pretty exciting. You, sir, had a question?
Yeah, security and privacy. How do those play in that?
When you say security, what do you mean?
a drone being used for purposes that it shouldn't be. People taking one, putting it in places underneath, or somebody running it over somebody's house and taking pictures of whatever.
So, we are general purpose technology and we're open source. So there are no limitations whatsoever on our.
Good or evil?
You can be used for good or for evil. You can use a personal computer to do your email or to hack into the Pentagon. It's kind of like that. We don't limit the technology. We do, however, use our community power and our community to promote safe and responsible use. So we're hardcore about FAA restrictions. We've also invited all the military agencies and sort of defense agencies to come into our community to participate. We do quarterly checkups with the FBI where we let them know what's going on. I fly to Washington and brief the agencies to inform them. I mean, I don't think that it's my job to limit the technology, even if I had the power. I don't think it's my job. I think it's my job to as a citizen, to inform those who are tasked with protecting us about what's possible, about what the risks are, to do everything in public so that they can see what's going on and let them do their job better. So we take our sort of promulgating good practices and informing agencies' responsibilities very seriously, but we don't limit the technology. And as for privacy, once again, technology has made a mockery of the laws of the land, right? So we don't know what there are massive jurisdictional problems. Let me give you an example. Privacy in the United States is a local matter. It's based on community standards and what's called the reasonable expectation of privacy. Every community has different rules about privacy and what kind of, what you're allowed to do, what the police are allowed to do, etc. In the United States is the way we do things locally. The airspace is regulated federally. I live in Berkeley. Berkeley would very much like to ban drones. Unfortunately, Berkeley doesn't control its airspace. The FAA controls the airspace. And so there's a jurisdictional problem, which is that privacy is local, but the air is global, or federal, in this case. And the FAA is not in charge of privacy, and Berkeley City Council is not in charge of the air. Go figure. Yes, sir?
Is there something like building street view for drones?
Absolutely. It's possible. It's illegal at the moment.
It is illegal.
Well, because the FAA doesn't allow use over built-up areas. So right there, I've just shown you flying over our offices in Berkeley. That would not be. It's not a law. It's a regulatory guideline, but that would be a violation of the FAA's regulatory guidelines.
What is the radio range?
The radio range is a mile or two. But we stay
For
within,
that one?
We stay within, we stay within visual line of sight. So we try to stay within a half mile or so.
And where do you see 3D robotics in 5 years?
Well, we just closed a $5.1 million round. VCs don't invest in companies that don't think are going to be big. We've been growing more than 100% a year for 3 years, and again, we'll probably be around 10 million in 2013. So you just do the math. We get to 100 million pretty easily.
Right.
I think we're going to have, that 14,000 square feet in Tijuana. We probably should have had 140,000 square feet. I mean, we're going to start with that. We've got electronics. We've got CNC. We're going to add injection molding, then foam, then.
Okay.
I mean, maybe we're going to be Boeing.
Just one, congratulations. And one more question. Have you been approached by other companies to use your drones for their own commercial use?
Every day. John can tell you. Where's John? Oh, John. Yeah, John, we get approached like
because this is really
10 times a day. I mean, agriculture, every day, scientific. Oh my God. John, the question was, do we get approached by other companies to use our technology?
Yeah, that's probably one of the more interesting parts of the job is you get to hear from people with ideas that you never could have come up with on your own.
Right.
What was the latest? Edge detection of gopher holes. Fake condors. Fake circling condors to lure endangered species to go to safer neighborhoods.
To relocate endangered species.
Wetlands conservation. Louise Leakey doing it for architectural digs.
Invasive species as well, so other people want to be able to, essentially photograph a plot, an area, and identify invasive grass species and stuff like that, so they can eradicate them more easily. I like the conservation aspects. I like the agricultural aspects. It's great.
Okay.
Tomato ripeness, wheat blight, you name it. Yes, sir, in the back.
How often do you guys pursue those prospects? Or do you kind of just focus on the platform itself?
Yeah, so we're setting up an OEM VAR relationship. So we have an open platform, and what we know nothing about tomato ripeness, right? But there are people out there who know a ton about tomato ripeness and know nothing about drones. So we're an OEM, and we basically have an open platform. So if they want to take our technology, take our platform, and brand it, or add some feature to it, or maybe an image processing function, or some service to it, and then charge whatever they can, that's great. So we basically think there's an infinite number of verticals out there. I mean, I just said agriculture is in one vertical, but every crop. Some of those crops, the biggest problem is moths, which are pests, and the moths only come out at night, so you need an infrared solution that can do the crop surveys at night. Others can use optical, some of them need multispectrals, some of them want stills, some of them want video, some of them want stitched together, some of them want image processing done after the fact to highlight problem areas. There's like a zillion verticals out there, all of whom are going to be transformed by drones, and we don't know anything about any of them, but we don't have to. If we can set up an API, kind of interface, by which people can use our open, because we're the only open platform out there that does autonomy. All the others are closed platforms and cost $10,000, and you can't add a tomato ripeness detection algorithm to a closed platform, but you can add it to ours. So we think that the open system uniquely enables us to kind of serve those verticals with an OEM kind of bar.
So you will always using Arduino for your...
No, we don't use Arduino anymore. Actually, I mean, that was our last Arduino program. Now we use the Cortex M4.
Okay.
So we still use the Arduino IDE. So it looks like Arduino, but it's now a 200 megahertz, 32-bit, big ass chip.
Okay.
Yes.
So can you shed some more light on the pricing decisions that you had in the beginning and across the 3 years, and distribution model, and also sourcing, like all...
Right. Pricing was simple. We said we sort of, a couple smart people here, the evil mad scientist people in particular, sort of taught us the 2.6 rule and never looked back. Pricing simple. We just, take out a calculator. 2.6 times the bill of materials. You said source distribution. We have about 40 some distributors. We have liaison with distributors. We sell them wholesale. They sell retail. That's
so you have 40 for each. Wholesale is 40, and then
so we charge like 1.6 times to the distributors and 2.6 to end consumers. And supply chain management is the job that's never done. So we have a whole team that does nothing but efficient sourcing, 30 net, 60 net, volumes. As we get bigger, we can buy volumes. But our ERP systems, we're using Spree for an e-commerce system, so the back-end integration to project demand. And as you guys know, China just went on the Chinese New Year. So if we didn't have some experience in this, we would have been sort of caught 2 weeks of missing inventory because of Chinese New Year. Because we had some experience with this, we now were prepared and ordered ahead of time with enough buffer in our supply chain.
So what is 2.6?
40%, 40% margins. You kind of do the math and you end up with 2.5 something. Yes, sir.
In the track so far, what are can you share some of the things that end up being more expensive than you expected, or some expenses that were...
Customer service.
Higher.
Yeah, I mean, we have a super complex product. I mean, this is like, a flying robot. And so lots can go wrong. And the only thing harder than a flying robot is a flying open source robot that you can put on any vehicle and like plug in wrong. And so, complexity. What a disaster. Oh my God, so the most expensive mistake we ever made was allowing people to solder stuff. People suck at soldering. And we thought we always save like 30 cents in soldering, and you end up with like dollars worth of customer support costs because people screw it up when they solder, and then it voids the warranty, and then they're pissed off because they say, well, how can I not void the warranty if I got to solder on the connectors? And anyway, we have DIY in our name. We came from the maker world. We love soldering, but with regret, we had bad soldering. The second thing was boards. We're not selling boards anymore. We're putting everything in enclosures. Again, we just don't want boards. Scare people. They just want this. They just want things like in a box that just work. Yeah, we ban compilers. We ban code. I mean, when I say ban, you can. All our code is open. You can use a compiler, but you don't have to. And so basically we're taking every day, we try to take something complicated out of the process and just eliminate it. The configuration, that should be a machine learning function. And this one right here, I mean, just maybe this may look cool to you, but this drives me crazy. So see these things there, these are called motor controllers. You should not see those. Those should be invisible. When you set up, you actually have to do a configuration process by which you teach the motor controllers what your radio output is. It's crazy that we should do that for you. See these wires? You should never see wires. See this battery? You shouldn't see the battery. These screws, it all just drives me berserk. And these are barriers to entry. When we take, when we add features, it doesn't move the needle for sales. When we subtract complexity, it blows up sales. The biggest barrier to selling is confusion. I don't know. I don't know what to do with this. I don't know where to start. And if you take confusion out of the equation, suddenly sales explode.
So the wires thing you mentioned was replacing the wire connections with just regular connectors.
Yeah. So I mean, since you asked, so what I'm looking here is there's these 4 motor controllers. There's a power distribution board. There's this thing right here, which is a voltage and current monitor and a power regulator. There's another board that does LED control. We just shrink it all down to one PCB. Right. Got rid of all the wires. I think there were some other questions over. Yes, sir.
I have a question about operation time.
Yeah.
Battery. So I'm thinking of application like night patrol. So like autonomous navigation,
right,
and night vision, and
right,
motion detection.
Yep.
I can cover that.
Motion detection is a little tricky since the vehicle is in fact in motion. But
I'm thinking of a totally separate camera module. But the thing is, operation time. I'm thinking of like a few hours.
Yeah. So you wouldn't use a copter for that. You would use an airplane. So we happen to bring one of our rotary vehicles, but we also do airplanes. And airplanes can be in the air for hours.
I mean, with copter. So I think the operation time is too short. So maybe I can have some kind of auto recharging ground station, something like that.
Right.
But do you have any plan or?
Yeah. So there's another thing. So let's say this is an electric powered copter, and for a multi-copter, that's all you're going to get is electric power. So you're dealing with 20 minutes. You're really not going to get past 20 minutes. If you want to move to a gas-powered traditional helicopter with one blade, then you can start to look at about an hour, because gasoline has so much more energy density, and we support that as well. It's a bigger platform. It's more dangerous, more expensive. But if you want an hour in one position, you can do that. By the way, if all you want is just to have a camera in the sky, put it on a balloon. That's actually it's called an aerostat.
Yeah, but the wind,
The wind is a small issue. Now, if you want to go to multiple hours or many miles of distance, then you want to go to an airplane. Electric airplanes max out at about 2 hours. If you want longer range, you go to a gas-powered airplane. Now you can fly across the Atlantic if you want. What you described is a multi-copter, is a copter thing that's maybe landing and recharging. So right now, commercial GPS is about a 2-meter accuracy. By using some sort of smart sensor, algorithms in the accelerometers, we shrink that down to less than 1 meter. So we can hold within a 1-meter box. But if you need to land on a charging, on a charging station, that might not be good enough accuracy. So what we have is what's called a differential GPS. So what you do is you have a beacon, you have a GPS on the ground in a known position, and then you have another GPS on the aircraft. And then all the atmospheric disturbances that introduce noise in the GPS signal. If your one on the ground just says it moved a meter to the right, you know that was noise. And so you subtract that meter from the one in the air. And then you can get to sub-centimeter. You can get to centimeter level resolution. At that point, you can land pretty reliably on a charging map and for an inductive charging. Now, weather is a whole other issue, and rain and snow, and but to answer your question, it's doable. We don't offer that solution right now. Any other questions? Yes, sir.
Yes, you're very tied to your community, which is developing the software and creating a lot of the innovations on the interesting things you can do in those verticals. What do you do besides creating the space online for them to collaborate, to get involved and inject yourself with that community?
What do we do besides?
Besides creating the space online.
So we have a community, which is an open community. Then we have a structured development environment on GitHub. So we have version control, we have dev teams, we have weekly dev calls, we have dev lists, we have IM channels, we've got some paid contributors who are dev team leaders. We have a process by which other people are brought in, given roles and responsibilities, and we've got DroneCon where we do a curriculum thing. We've got documentation teams. I mean, it's a big operation. But the simple answer is the community is the sort of the low. You just go there and kind of learn about stuff, and the moment you want to work, you want to do something, you move right into our development environment, and that's built around GitHub.
Maybe one last question, and then we'll let people circulate and ask you offline. Right.
What are the main technological advances that would really help you make your product cheaper, better?
The things we're looking at right now are largely in the optical space. So just today we released a really cool optical flow image processing board called PX4 Flow, which is awesome. We're looking at sort of $20 LiDAR solutions. We would love a sub $100 IR camera, infrared camera. Some of those night vision, some of those night analysis things. We would love broadly a sense and avoid technology, a broad way, because right now we can avoid the mountains that we can see on Google Maps, on Google Earth rather, but we can't avoid birds because we don't know about them, and we can't avoid telephone lines and trees and things like that. We don't have sense and avoid technology. We think that our optical solutions are a path to sense and avoid, but we're not there yet. A SLAM, so we've been talking about navigation in a GPS space, but inside you typically don't have GPS, so cheaper SLAM solutions that allow these things to navigate internally, inside buildings it would be another big win. We would love batteries to get better. I don't know. Were those the kind of answers you were hoping for?
Definitely.
Okay.
All right.
Yeah, one last one.
Sorry. What about RF links? What do you for video especially, point-to-point RF is a major issue.
We have designed our own radios. So we opened, we like the XB, the Zigbee standard, but we like open source better. So we just created a better standard called the 3DR radios, which is, it's open source and fully configurable, just better than XB and half the price. Thanks to the kilometers now, 1/3 the price. But that's for our data telemetry link, and that caps out at about 115K. Right. For video, the industry is standardized on analog. It's just really hard to send digital video, compressed digital video over an RF link without sort of crazy ham licenses or military frequencies. So we use 500 milliwatts analog video transmitters, and then we digitize on the ground. So we're limited to VGA. So what we do with something like the GoPro, as you probably know, the GoPro has 2 video outputs. So it's got a VGA real-time output and then records in high def. So we transmit the VGA output to the ground and then digitize it with our laptops, and we in fact project it on the heads-up display while it's simultaneously recording in high def on the board, and that's sort of good enough for our purposes. There are military-grade, long-distance, high-definition digital video radios, but they cost like tens of thousands of dollars. Anyway, it hasn't been a big problem.
I think at this point we're going to close up because I want to make sure you guys get a chance to meet with each other and ask Chris or meet Chris kind of in a smaller group. So thank you, Chris, for your time again.